Hi. So, I have something new to show, very much inspired by the recent meetup sessions of the 52 Living Ideas with Tom Miller, the mastermind behind naturalmodular.com. And there's something about the coordination that Tom is using for his method that I found deeply satisfying and intriguing, and I was trying to show you this thing yesterday and went on a tangent and never got to it and then got disrupted, so I'm not going to go down that way again. There's something more to be said about it, but here this is directly inspired by Tom's work because I saw him show a specific model to Shrikant, which in his case he used table tennis balls, and I guess he glued them together. Now this here is not table tennis balls and there's no glue involved, it's just beads and string, so it's a proper tensegrity. And someone told me yesterday on another post that what I'm doing isn't a tensegrity because the things aren't floating, but really the fact that these beads are touching ever so slightly does not change the fact that it's a tensegrity. I mean, they're touching not even on a molecular level, they're just touching microscopically. Anyways, what is this model about? It's not about the sticks in here. Those are just something I figured I could put in there, so I did. But I'm going to remove them. Well, what is it? It is as I would call it, a three-frequency vector equilibrium. So these are closest drawn spheres, and on this outside layer we find 92, which I guess is 7 dozen 8, perhaps. 7 dozen is 84. Plus 8 should be 92. Yeah. And these are closest drawn spheres. I don't pack them, and I think closest packing is a misnomer. But this is a special model, again, as inspired by the model that Tom Miller was using. Because this is sewn together, as you might be able to just tell by looking at it. So what happens if I take out, or not take out, but open up this this seam? Of course it's going to take a moment, and I might speed this up afterwards, because no one needs to watch me fumble away on these for too long. Should have gone the other way around. Let's go that way. And perhaps let's take a tool. And while I'm at it, shout out to Mikko Snellman, maker of finest tools for rope work and rope work and modern spike siege. Oh no! Worst case. Dropping the camera. I'm sorry. And this is only just the outside layer. How many more seams is there? We shall see how far we need to open this to actually get at the next layer. But note how the seam is self-stabilizing, self-locking. I mean, even though I'm using a tool now to take it out, I did not need a tool to sew it together, because there's plenty of room to feed a string through, and it's possible to really lock the string into these places here, into these corners, because there's so much tension there already, and just pulling the string into that corner is clearly making this super tight, and yeah, just locks the string in place. Alright, I think I'm gonna try to see. This should be perhaps enough. Yeah, let's see. Alright, so this is the outside layer, and inside of that, look at that. It's a nest. Same thing, one frequency lower. And this is, I think, a good place to note and to point out that this is a model that is inspired by the one that Tom Muller is using. However, it's behaving vastly differently, because these beads aren't glued in place, so they can actually move, and this is where all the glued models with their microtriangulation make it seem as if this was a shape stable as this, when really these non-triangulated squares are basically offering ranges of movement for this whole membrane. And now that it's hollow, and I took out the inside and the seam, I mean, if the seam was still on, it would probably behave a bit differently, perhaps a little more like a 1,008 eyes. But it clearly shows how this is now transforming, and it's almost like a ball with too little air in it, you know. It needs the contained air to be in tension around, to be stable in its shape, and once the air is out, the whole thing begins to collapse or contract or whatever. Alright, I hope this works with the hard light. I did not anticipate that, but anyways, here's the next layer. You can see it's now a two frequency. There's yeah, that's better. There's 3 spheres, And with the 3 spheres we have 2 intervals, so it's a 2 frequency, where this one had 1, 2, 3, 4 spheres, and because of that there's 1, 2, 3 intervals, 3 frequency, 2 frequency. So this is a total of 3.5 dozen spheres, also known as 42. And I've checked yesterday again, nobody mentions this on any of the Wikipedia threads on 42. Seems Bucky's insights have not dissipated far. If they did, I guess people would know about this, and I consider this perhaps one of the more significant occurrences of that number, 3.5 dozen, 42, in the world, I guess, in the universe. Alright, so this is now open, I hope, perhaps not far enough. Yes, it's enough. So we can open this, and it's the same thing, it's just another layer, another membrane, and within this we find the 1 frequency vector equilibrium, the dozen around 1 spheres, but this is also a membrane that is open. See, I haven't completely closed the triangulation here, so it actually allows the nucleus to come out there. So that's the 0 frequency, sub-frequency. It's still the same structure, although this is a super high frequency sphere, so it doesn't immediately show, but in a way every sphere still has this quality to it, this nature of the vector equilibrium, or as I call it, the 2 dozen 8 eyes. So that's the first frequency, and we can put that in here, that way around. To frequency. To frequency. And here is the 3 frequency. And of course, this goes to say, or goes to show, that one can continue growing layer by layer, like an onion or a tree, around this. And in this case it is a this structure here, that all of these spheres, when they are closest drawn, get into altogether, is what Bucky called the isotropic vector matrix. Other people call it the space frame, or Bucky also called it the octet truss. I would call it the space-time frame, because this is space-time. Yeah, and again, I would not consider this closest packed, and also I wouldn't equate it entirely with the mathematical convention of the FCC closest packed spheres, face-centered cubic, because I don't see them realizing that this is actually omnisymmetrically arranged around a central nucleus, and I think that is way too significant to just overlook. Also, closest packing, in my mind, has its origin with the historically with the packing of oranges, or also cannonballs, which were which were stacked on ships for war, of course. What else? And they would pack them closely, tightly. But that is something, that's a special case. In general terms, if there is no Earth or other planetary or stellar body drawing this to its membrane so that we could stack them or pack them, then if we're speaking generally in terms of space-time where gravity is working omnidirectionally, it seems more reasonable to consider this closest drawn spheres, right? Because I can always draw them as close as they get, but that doesn't depend on the presence of somebody drawing them down so that I can pack them. Yeah. Alright, so that's just a look into this model, and I might go into a deeper dive into my fascination or happiness about the natural modulus coordination system, because there is something in it that is, I think clearly a consequence of using synergetics to begin with, which I think is an indicator of integrity and like a basic understanding of the nature of space-time. And yeah, I'll talk about that another time. For now, this is sweet and exciting, and now that it's open it's a little softer, but when it was all closed and sewn together, this was a very dense and very strong and stable structure. It's basically this is like nuclear physics on a macro scale or a meso scale, a mesocosmic scale. Smack in the middle between the micro and the macrocosm. And I think, we can play a lot in this layer of reality, and since space-time is essentially fractal, what we learn on this level applies on the small and the big.